So this one is exercise that is related to the circular motion. First, we have the MCQs, a turntable playing a vinyl record, rotate at a 33 revolution per minute. What is the angular velocity in radians? So omega, we need omega. So omega is equals to theta divided by t. One revolution is how many radian? 2 pi radian. And how many total revolution are there? 33. The 2 pi multiplied by 33 will give us a total number of revolution, a total number of radians. Because like in one revolution, it's equals to 2 pi radian. And time is in minutes, so we have to convert into seconds. So we have to divide it by 60. So 2 pi multiplied by 33 divided by 60. So what will be the right option for this? So it will be C. A DVD rotating at 270 rotation per minute. We want to convert into radian. One rotation or one revolution is 2 pi radian. So 570 multiplied by, because one revolution is 2 pi radian. So 570 multiplied by 2 pi divided by time again in minutes. So we have to convert into seconds. So divided by 60. So that will be equals to C as well when you simplify. Substitute the value of a pi, which is 3.14. In question 3, a student investigate the magnetic flux through a coil with an angle in radian to magnetic field varies with an angle in radian. Which of the following gives the equivalent angle radian for 40 degrees? So we want to convert, like example, 360 degrees is equals to 2 pi radian. So if we have 40 degrees, how many pi radians will be there? X cross multiply. So this X will be equals to 2 pi multiplied by 40 divided by 360. So 2 pi into 40 divided by 360. The toy airplane makes 14 revolution. So one revolution is 2 pi radian. So how many radians are there? So it will be 14 multiplied by 2 pi and divided by time, which is equals to 6. So 14 into 2 pi divided by 6. So that will match with option B as well. The diagram shows a coin on a horizontal surface which is rotating at a constant angular speed, velocity omega. Which arrow correctly shows the direction of the friction? Look, this object, whenever object is moving in a circular path, there should be a resultant force which is directed towards the center. So in this case, the frictional force is opposing the motion, so it's directed towards the center, so it will continue to move in a circular path. That's why D is the right answer. So friction is opposing the motion, and so that it does not skid or slide down, directed towards the center. The angular speed of the earth about its axis. So how we can work out the angular speed of the earth about its axis? The axis of the rotation of the earth is slightly tilted. So it is taking 24 hours for one complete. So we need omega. Angular speed means omega, which is theta divided by t. So one complete revolution, the theta will be equals to 2 pi radian. But what about the time period? The time earth is taking 24 hours. So 24 hours, we have to, like 1 day or 24 hours, we have to convert into minutes. So we'll multiply by 60. Then we have to convert into seconds. So we'll again multiply by 60. So this will give us a time in second. And this one is in the radian. The one revolution is 2 pi radian. So we get 7.3 exponent minus 5 radian per second, which is the angular speed of the earth. The picture is of a child spinning a top. The diameter is 22 centimeter, and so we have this diameter which is 22 centimeter, so radius will be 11 centimeter. And it spin at a rate of 6.5 revolution per second. So it should be radian, the speed of a point of the outer edge. So how we can work out, we have the formula. Outer edge speed, the linear speed, so V is equals to R omega. So where R is a radius, which is 11 centimeter, 0.11 meter. And omega, this is omega, but that is given in revolution, 6.5 revolution per second. It should be in radian. So how to convert revolution into radian multiplied by 2 pi. So this will give us omega. And time is per second, so time is 1 second, because omega is equals to theta divided by t. So it is 6.5 revolution, we convert into radian, and time is 1 second. So when we multiply, this will give us the speed at which it will move, 4.5 meter per second, the linear speed. In question 8, a fairground roundabout makes 8 revolution in 1 minute. So we need omega. Omega is theta divided by t. 8 revolution we have to convert into radian. We multiply by 2 pi. And in 1 minute, so time is in minute, we have to convert into second. So this will give us C as a right answer. In question 9, a car of mass m over a circular humpback bridge of a radius r with a speed v. When it is at the top of the bridge, the force on the car from the bridge is given by. So we need a normal contact force here. So the weight of a car is acting downward, the normal contact force is acting upward, and because it is moving in a curved path, so the force which is directed towards the center should be more than the normal contact. So W is acting downward, R is acting upward, and as a result of these two will create a centripetal force. So the centripetal force is equals to weight minus R. And we need the R because the question is what is the, when it is at the top, the force on the car from the bridge. So we need the normal contact force. So if we need R, so R will be equals to W minus centripetal. So weight is mg, so we write mg, and centripetal force is given by a formula mv square over r or mr omega square. So mg minus mv square over r, so it matches with option D. In question 10, a particle completes 6 revolutions in 6 seconds. The angular velocity. So we need omega. Omega is equals to theta divided by t. So 6 revolution multiplied by 2 pi divided by 4. So that will be equals to 9.4. So B will be the right answer.